G'day mates, I'm Dr. Flemming. I'm from Australia, down under. I wanted to thank you for giving me the opportunity to talk to your class today. I really wanted to take this time to talk about plate tectonics. Do you know what that is? Plate tectonics? Well, let's start from the beginning. Now, the Earth is about 4.5 billion years old, and it's been changing ever since. The Earth is made of different layers. Now, we live on Earth's crust. It's about 30 kilos thick. That's 22 miles for you blokes. Now, if we had a model of the Earth... Oh, crikey! I have a model of the Earth right here. If we could take this model and open it up, we would see the layers. Let's talk about the layers of the Earth. Now, of course, we already talked about the crust. That's this blue layer here. The crust, remember, is 22 miles thick. That seems like it's thick, but it's really not compared to the rest of the layers. This yellow layer here, this is the mantle. It's a thick layer, hard as rock, but it moves very slowly, about as slow as your fingernail grows. Isn't that great? Now, let's take a look at this red layer. This red layer, this is the outer core. It's liquid, made mostly of iron and nickel, and it moves around the inner core. The inner core is a solid about, no, not about, it is actually way hotter than the sun. And it is also made of iron and nickel, but it's a solid. Now, the motion of this hot melted metal moving around the inner core is what gives Earth, or what makes Earth, appear to be a giant magnet. But enough about that. Let's talk about the most important part, the plates, which is why we're here, is plate tectonics. The plates are located in the mantle, just below the crust. Now, Earth's crust and part of the mantle is broken up into pieces of rock, and these rocks are called plates. Now, if you look around, the Earth seems like it's very still. Just kidding. The crust and the plates are actually moving all the time. They're actually floating on the Earth's mantle, that hot, melted, molten rock that moves very slowly. And because of that melted rock, the plates move in all different directions. When the edges of these plates come into contact with each other, great things can happen. So let's talk about plate boundaries, shall we? The first type of plate movement is a convergent plate boundary. What do you think happens there? Well, I'll tell you. At a convergent plate boundary, the plates are forced together, squeezing and pushing and causing the Earth to buckle and fold under pressure. And guess what's formed? Mountains. The second is divergent plate boundaries. Now that's opposite of convergent. Divergent means the plates separate. Now, when they separate, oh crikey. Oh, sorry about that. Now, when the plates diverge, it leaves open, gaping holes in the Earth, and lava is able to seep up through the cracks, causing new Earth to be formed, new rock to be formed. And if it happens on the bottom of the ocean floor, guess what type of new Earth is formed? ocean floor. It's called sea floor spreading. Now, if divergent plates happen on land, we've got all sorts of things happening like valleys and troughs and all sorts of things. The earth is opening up. Now, the third type of plate movement is the most exciting, a transform boundary. Transform boundaries is when you have two plates that are slipping and sliding and grinding next to each other. When too much pressure builds up, the rocks snap and an earthquake happens. Did you know that in Oklahoma alone last year there were over 250 earthquakes? You know what that means? It means there's a lot of plate movement going on. Well, blokes, it's time for me to go. Thank you, Mrs. Martin, for giving me the opportunity to speak to your class. And thanks to the lot of you. You were a great audience. Hey, if you're ever in Australia or down under, come and see me.